Today we will be graphing sine and cosine curves. So our sine and cosine functions, they are examples of periodic functions. A periodic function is simply a function that will repeat after a certain period of time. They're periodic. So examples in real life can be modeled using a sine or cosine curve. Some examples are high and low tides, movements of planets, anything with springs like yo-yos, and sound and light waves. Those are just some examples of some applications we'll be looking at in the coming week. So before looking at some applications, we want to be able to take the values in the unit circle, which I've already pre-written here, and graph them with our horizontal and vertical axes, where the input will be our angle, the output is, for sine, will be our y value on the unit circle. Now with applications, our inputs could be time, for instance. So if you visualize on the unit circle, again, these are already pre-filled out, but at 0 degrees or radians, the y-coordinate will be 0. As we move up to pi over 2, the y-coordinate is 1. Moving down to pi, the y-coordinate goes to 0. 3 pi over 2, the y-coordinate goes to -1. And then we're back at 0. Now notice after that it's going to repeat in nature, hence the periodic fashion. So we're going to plot these points here. Plotting 0, 0. Our next one at pi over 2, we're going to be up at 1. At pi, we move down to 0. 3 pi over 2, we're moving all the way down to -1, and 2 pi, we'll be at 0. Now, of course, I could have plotted all of the points in between, and you would get this nice curve if I did go to plot pi over 6, pi over 4, pi over 3, and you would get a nice looking curve our sine curve like this. This is one period, or one cycle, I should say, of our sine curve. Now notice after this, it will just repeat in nature, go up to 1, down to 0, down to -1, and so forth. It goes on indefinitely in each direction. Okay. What we're doing here is just graphing one cycle. Okay. So when we ask what is the period of sine of x, the period is simply 2 pi, because it completes one full cycle and then repeats after that in 2 pi. Okay. All right. So we can do the same thing with one cycle of cosine. And here I've pre-filled the x coordinates on the unit circle with respect to the inputs or the angles. Use this different color. So at 0, we're actually going to be starting up at 1 at a high point. At pi over 2, we're going to be coming down to 0. At pi, we bottom out down here at -1. 3 pi, whoops, that should be a 3 pi over 2. We should be coming back up to 0. And at 2 pi, I should be up at 1. And once again, I could show all of those intermediate values. If you were to take the time to plot all of those points, we would get this nice cosine curve like that. And once again, because it is periodic in nature, it's going to repeat that pattern in both directions. So the domains of sines and cosine curves are all real numbers. But when we graph a cosine or sine function, we typically will say graph one cycle or 2 cycles. And so we are essentially just graphing one portion of the curve. Remember, it is going on forever. Okay, so again, once we say what is the period of cosine of x, it is 2 pi as well. Okay. So these are your two parent graphs. Just remember, when we go down here, now we're going to formalize this whole new function. Sine of x can be shifted using our transformations as with any of our graphs that we've worked with before. Notice they have different variables though. The A we've worked with. B we're going to talk about tomorrow. This is our frequency. It will help us to find our period. C is our horizontal shift and D is our vertical shift. So they just give different letters here. We'll see how to use those to graph a sinusoid. What you do want to know, and I'll write these up here again, is the parent graph of y equals sine of x. You know it's always going to start at 0, 0, go up, and finish down at 2 pi. So from 0 to 2 pi, it's completing one cycle. Y equals cosine of x, parent graph, starts at 1, come down to 0, down to -1, back up to 0, up to 2 pi, or up to 1 at 2 pi. Okay. So again, we're just going to be transforming that, shifting it left, right, up, down, flipping it. Remember, same rules apply with this A value and so forth. Okay, we have some new terminology, some terms to know here. So A, and I should say actually the absolute value of A is going to be called our amplitude. Okay, and this is essentially just the, and we'll show this on a graph, it'll make a little bit more sense when we put one together, but it's the distance from the midline to the max or min. Okay. All right, D is going to be our vertical shift, just like our HK. And this ends up being the midline. Okay. C is usually our horizontal shift. But of course, with graphing sinusoids, they give it a new term. This is called our phase shift. Okay, so just some new terminology. C is our phase shift. Okay. B is called our frequency, which is not very useful, but the period is going to be more important, and we'll talk about this tomorrow, but this helps us to find the period. Okay. So I suppose I could graph a sinusoid here real quickly. Notice this one has been shifted up. I'm going to graph this midline. This would be my D value. And it's basically the line that this sinusoid has been oscillating about here. So it's that middle line. Now, just to visualize what the amplitude is this distance from the midline to the top peak or from the midline to the bottom peak. That has to be the same. So that's your A. Okay, and we'll talk about the rest of these, kind of just putting together some graphs on the back. All right. So, I'll go ahead and erase all this. Thought that was erased. Okay, so our objective is we want to be able to give some information, or actually a graph being given an equation, or we can be asking you to find an equation given a graph and so forth, or we might ask you for all of this information, the amplitude, period, phase shifts, sinusoidal, axis, midline, all that good stuff. So we'll start with some easy ones. Okay, well, when I see 4 sine of x, we know that this value out here is my A. That's the only thing here, right? So let's go ahead and rewrite this here so we can refer to it. a sine b x minus c plus d. Okay, remember we're not dealing with b today. That will be tomorrow's lesson. But all this means is that if I have my parent graph of sine of x, it usually has a max value of 1 and a min value of 1. So my original amplitude is simply 1. Some people like to sketch the parent graph first, completing one cycle in 2 pi. Max is 1, min is 1, negative 1. You don't have to graph that, but just to visualize it our first time. Now it just says that now my amplitude is going to be going up to 4. And let me move that up a bit. And down to negative 4. So we're just having this vertical stretch. Okay. Where that a value is 4. And this is all you need to do on your homework tonight is we're practicing sketching one full cycle of the graph. Okay. So the second example, we have negative cosine of x plus 3. So knowing what our parent graph of cosine looks like, sometimes it helps just to sketch it. Typically starts up at 1. I kind of like to say it looks like a saddle. Completes one cycle in 2 pi. And this negative is going to reflect it or flip across the x-axis. And this plus 3, we usually say is a vertical shift, but it's now called our midline. Okay, so notice the midline is usually the x-axis. That is going to be shifted up 3. So I like to shift this up 1, 2, 3. I'm going to shift that midline up. Okay. And since it is a horizontal line, I should name the midline y equals 3. Now the amplitude is 1. Okay, it's the absolute value of this negative 1. That just means from the midline, I'm going up and down 1 for my max and min points. Now, typically the cosine would start up here, but because it's reflected, I'm going to be starting down at 2 and having a max up at 4. Okay. We'll start here at negative 2. Have a max at 4, and again, we're going to be ending at 2 pi because we started at 0. So I've sketched one full cycle of this curve. A lot of students ask how much detail do we need on these graphs? Well, of course, you want to sketch your midline. And I need to see the y-axis labeled, so your max and min points. Okay, the general shape of the graph, and I need to see on the x-axis the beginning and end value. Okay, some teachers have you also label all those key points in between. It's not that difficult on this one. Midway between would be pi. This one would be pi over 2 would be where it's hitting the midline, right? And then this would be 3 pi over 2 and 2 pi. So you do have 5 key points there. All we care about typically is the starting point and the ending point. Sometimes those middle points are kind of a pain to find. Okay. All right, let's look at another one. So all we have going on here now is this value inside the parentheses, which is now a new term. It's called a phase shift. Okay, so the phase shift is essentially just going left or right. Opposite, same rules apply. So we're actually going pi over 4 to the right. Okay. So our parent graph, the basic sine curve, I'm just putting in dashed lines here. Whoops. Typically starts at 0 and ends at 2 pi, where this would be pi. And we want to shift that pi over 4 to the right. So, whoops, wrong way. Okay, so pi over 4 would be right here. And that just means we will be ending at what point? Well, we know this period is 2 pi, so if you think pi over 4 plus 2 pi, that whole distance of that one cycle has to be 2 pi, should be 9 pi over 4. My end point should be 9 pi over 4. All right, final curve. All right, example 4 has a lot to put together here. So we have our sine curve. Some people like to do these all in steps. I kind of do it all at once. Whatever you're comfortable with, just keep track of all these little shifts. And typically how we have it asked for, like on a test, we'll ask for the amplitude. That will be 3. What is the phase shift? That is negative pi over 2, or going pi over 2 to the left. And the midline is going to be y equals -1. Also, the period, all of the periods today will be 2 pi. Like I said, those will change tomorrow. Okay, so this is all this key information. Make this a little smaller. All right, and we need to put that all together. Also, knowing the general shape of the sine curve, I always like to write this right away. We know it's initially looks like this, but we are flipping it. So a negative sine curve is going to be going down and then up. Okay, so this is a negative sine. All right, so we know we are going left pi over 2 and down 1. Again, I always like to start with the midline being at -1. And then using my amplitude, I need to go up and down 3 to find my min and max. Okay, so I'm going to go up 1, 2, 3. So a max of 2, and 1, 2, 3 down to -4. So those values should be labeled on your y-axis. And then the phase shift starting at negative pi over 2. Let me move this over a bit. And I know I have to start on the midline, come down, and end 2 pi later. So where should I be ending? My end point should be at 3 pi over 2. If I'm starting at negative pi over 2, and this is like what's hard for some people, you can write it out if you want, negative pi over 2 plus 2 pi, and get a common denominator. Should be at 3 pi over 2. That's my end point. Okay. Now notice this is oscillating about the midline, y equals -1. Okay. And the max point is at 2, min point at -4. Okay. And remember, this does technically go on forever and ever, repeats. We're just sketching one cycle. Okay. All right, almost done. Example 5. Sometimes we ask you to go backwards from a graph. So pulling out all of this information, the amplitude, phase shift, midline, period, from a graph and putting it together. Now it does say given the sinusoid. Sinusoid does mean it can be a sine or cosine curve. So there are many different correct answers here. You could write a sine or cosine curve. First, we need to find the midline. So let's look at the topmost point is 6, bottommost point is -2. So where would that midline be? It looks like should be at 2. Okay. Which means the amplitude should be 4. Double check that it's the same in each direction. Okay. So my A value is going to be 4. My midline, or my D value, right, is going to be 2. And this is where you get to choose depending on which portion of the curve you're looking at. Kind of hard to see on this. Where's my axis? Right here. Okay. If I do no phase shift, it looks like I could look at this portion of the curve. Let me use a bigger one. And if I'm looking at this being my point, my first point with no phase shift, that's a negative cosine curve, right? So I could write y equals -4 for my amplitude, cosine of x with no phase shift, and +2. Okay. So remember what we're writing this off of: a cosine b times x minus c plus d. B is always, we're not dealing with B right now, it's always 2. So we've got that written there. Now let's say I did not want to use this piece. Let's say I wanted a sine curve. Okay. Let's say I wanted this one right here as my first point. Okay, this will be a negative sine curve, and it also has a phase shift to the left of pi over 2. Right? So I could also write this as y equals negative, since it's flipped, 4 sine of, with a phase shift we would do x plus pi over 2, and it still has the midline of +2. So I could keep doing or writing a lot of different options here, depending on which point you're starting at. Okay. You could start at this point and do a positive cosine curve with a phase shift of pi. Okay. Lots of different options. These are just 2 of our options. So just make sure everything fits all of that key information. All right, good luck on your homework, and we will add in the B value, which will help us determine different periods tomorrow. Good luck.